Data transformation in SPSS. It is an essential step in statistical analysis. If you do have a data that are not normally distributed, whether it's positively skewed or it has an outliers, there are certain different ways to transform this data from being non-normal to become normal. 3 different ways. These are log 10, square root, reciprocal or inverse transformation. And I'm going to show you step by step how to do data transformation using log 10 for positively skewed data, data that has 0 values in it, and data that have negative numbers in it. And I'm also going to show you how to do square root for positively skewed data and data with negative numbers, all in SPSS. In this video clip, I will show you how to transform your data in SPSS using the log 10 and how to transform positively skewed data, data that has 0 values in it, and data with negative numbers. I have a data and we want to explore the distribution of this data and to find whether it is normally distributed or not. It is an essential step, and it is in fact the first step for statistical analysis of a data, is to explore the distribution of the data, whether it is normally distributed or not. If it is normally distributed, then parametric test will be used for the analysis. If it is not normally distributed, 2 options available: either to transform the data so they become normally distributed through 3 different functions. One of them transform the data through the log 10, or use a non-parametric test for analyzing the data. So here in this part, we'll show you how to explore your data, how to transform non-normal distributed data, and how to deal with data that have 0 in it and data that have also negative values in it. So the first step here, I have a column called PS, which means positively skewed. I have already checked the distribution of the data and it was positively skewed. So I'm going to show you how to do that. First of all, click on Analyze, go for Descriptive, click on Explore, reset this. I'm going to move the positive skewed into the dependent list box, and I'm going to take statistic, keep it as it is. If I click on plots, I'm going to untick stem, tick the histogram, and then tick on normality plot with test. And options, I'm not going to do any changes. So if I hit the button for OK, SPSS will generate a table, and in this table, this data shows that these data are positively skewed 0.65, and the standard error is 0.1. And here also SPSS has calculated the test using Kolmogorov, Semenarov, and Shabir-Wilk test for normality of the distribution of the data. And as shown here, the data are not normally distributed. The histogram also confirmed that these data are slightly skewed to the right, so it's positively skewed. And so the next phase is, again, with this data, it is not possible to move ahead and do a parametric. We need to transform the data, and we will transform the data using the log 10. To do that, you click on Transform, then click the Compute Variable, reset this. So the SPSS will generate a new column. It has a variable in it, and that variable is based in computation. So we're going to name that column with log 10 positively skewed. Apparently, these data are positively skewed. So we notice here that there is a function group called arithmetics. Click on log 10, then move the log 10 into the numeric expression box. And we need to do a log 10 for these positive skewed data, which between here. And then if you hit the button for OK, what happens here is that SPSS has calculated the log 10 for this PSF, positively skewed data. Whether this data has been transformed or not, I will go and show you how to do that. Analyze, click again on descriptive statistics, click on explore, then move the log 10 positively skewed into the dependent list box. Click OK. And again, I will go straight forward for the test of normality. It shows here that once we have transformed the data using log 10, the data tend to become more normally distributed, as can be seen here by the two tests, Shapiro, Welk, and Kolmogorov-Smirnov. So the data become normally distributed post transformation with log 10. If we look at the histogram, see here it is positively skewed. That's before transformation with log 10, and this is the shape after transformation with log 10. So these data, this transformation of data has corrected the non-normal distribution and become normally distributed. Thus, parametric test can be used. Now, what do we do if you have a 0 in your data, or if you have a negative value in your data? Again, it's the same concept. And these data are also positively skewed. As you can see here in this column, we have a 0 value here at case number 10. And so what we are going to do is we are going to transform these data using log 10. But again, to avoid this 0, because there is no calculation for log 10, we have to transform these data in a certain way. So we click on transform, compute variable. Again, as we can see here, I'm going to generate a new variable and call it log 10 0 for column that has 0 value in it, or data has 0 value in it. And I'm going to again do log, move the log to here, and I'm going to use the data which has 0 value in it. And so the log 10 for 0 will not be calculated, so I had to add number 1 to it, so that the data, so 0 become 1, so log 10 can be calculated. So if I hit the button for OK, again, so if I have a positively skewed data that has negative values in it, or negative numbers like minus 3.6 or minus 1, as we can see here in case number 5 and case number 14. And if I want to transform this data, we need first of all to change this minus into positive. And the way to change minus to positive, so to do log 10 in it, is to add to the column a positive number. And in this case, I'm going to add, since it's minus 3.6, I'm going to add number 5 to every case on this column. The way to do that is to go through transform, compute variable, reset this, and then SPSS will generate a variable. We'll call it log 10 negative number. I'm going to select the log 10, and I'm going to move the negative value into the log 10. Add to this column number 5. So what does this equation says? Do the log 10 for the column labeled negative, added to it, to each cell in it, value 5. If you click OK, again, SPSS generated a column, has a variable in it, and the negative data has been transformed, and the data has been transformed using the log 10. So these are the way to do log 10 for skewed data that has no 0 or minus value in it, data that has 0 value in it, and data that has minus value in it. I will show you how to transform data in SPSS using a square root formula. And this square root can be used to transform data that are positively skewed and data that have negative numbers in them. And transformation of data is one way to overcome outliers in your data or a data that are not normally distributed. Here we have a data that is positively skewed, as I've already done checking on the data using Explore in SPSS. I will show you shortly how to do that. I have here a column of a data, and we need to check the distribution of this data before proceeding to any statistical test. So the first step in data analysis is to determine whether the data are normally distributed or not. And if it is not normally distributed, there are few options, and one of the options is to transform the data using a square root or other choices. So first of all, to check whether these data are distributed, here I have in this column a PS data that labeled as PS. PS stands for positive skewed data. So to check the distribution of the data, click on Analyze, Descriptive Statistics, Explore. I'm going to reset this, and I'm going to move the positive skewed data to the dependent list, and then I'm going to click at the plots icon. I'm going to untext them, take the histogram, take the normality plot with test, as I'm going to use this statistical test to determine whether the data are normally distributed or not. Click on continue. In the options, we're going to keep the options that it is, no changes to it. So we click on OK. SPSS will generate few tables. The one here have descriptive title. From this data we can see that the data we have are not normally distributed, and there is a degree of skewness, and the data are skewed, positively skewed, as the statistic error for it is 0.1. Now the next table here tests the normality of distribution of the data using two tests, Kolmogorov, Semenarov, and Shabiro-Willick. Again, these two tests confirm that this data we have are not normally distributed. If we look at the histogram of these data, we can see that it is skewed to the towards the positive value, so it is positively skewed data. So we cannot proceed with this data using parametric test unless we have to go for non-parametric test. But another way to overcome this is to try to transform this data to see if it is really can revert to normal. And the way to do that is to use a square root. So I'm going to delete this square root of the data. And the way to do that is to click at Transform Compute Variable. In this compute variable, SPSS will generate a new column, a new variable with data in it transformed using the square root. I'm going to call it square root positively skewed data. So, and I'm going to look for the square root function here in this box and then in the one below it. Click on the square root, click on move it to the numeric expression, and then I'm going to square root the data that are positively skewed. Then I'm hit the button for OK, and then SPSS will generate a data, as we can see here, a column, a variable with square root of the positively skewed data. So the next step is to check whether these square root transformed data are normally distributed or not. Then we click and analyze descriptive statistics, then explore. And then in this window, I'm going to move the square root positively skewed data into the dependent list and click on OK. Again, we can see here from this descriptive table that the data that are not transformed, the skewness was 0.65. After transformation with square root, it is reduced to 0.2. So there is a reduction of skewness. So this data tend to be more normal after transformation. Again, this third table, testing of normality using the two tests, shows that the positively skewed data is not normally distributed. However, when square root was performed in all the data, the distribution of the data become normal, as it's seen here in these two tests. Again, this is the data before transformation with square root, and this is the data after transformation with square root. So in fact, transformation has really transformed the data from non-normal to normal, which allow parametric tests to be done on this data. Now, what if I have positively skewed data, but it has in it a negative value, a negative number, like this one, minus 2.5 and minus 1.3? Can I still do a square root transformation? Yes. And the way to do that is to click on transform, compute variable, reset that, and then I'm going to name the target variable as square root negative. And again, I'm going to look for the function of square root, move the square root function into the numeric expression, and then I'm going to square root the data that are positively skewed and have negative number in it, and so there is no square root for negative number. And the way to overcome this is to add to each one of these data value or number in the column for the negative number, which will transfer these two negative value into positive. So I'm going to add number, probably go for number 4. So this formula is going to take the square root of this data after adding number 4 to each cell on this variable. If I hit the button for OK, again SPSS will generate a variable which has a data in it that has been transformed, and the negative values has been transformed into positive, and a number 4 was added to all these cases, and then square root we're taking, and then from that move ahead to the check whether these data are normally distributed or not. So in this video I had shown you how to do square root for positively skewed data and data that have negative values in it. Another way of transforming data in SPSS, data that are not normally distributed, or data that has an outliers in it, or data that are positively skewed, is to use a reciprocal transformation, hoping that this reciprocal transformation will revert the data from being non-normal to a normal, which will permit using parametric tests in SPSS. Here I have a set of data in a column labeled PS, and I'm going to explore this data and determine whether it is normally distributed or not, or there is skewness on it or not. And if it is not normally distributed, then we will try to use reciprocal transformation to try to correct these data and see if it is really can revert to normal distribution. First step to do is to check whether these data are normally distributed, and I'm going to click on Analyze, Descriptive, then click on Explore, reset this, and I'm going to move the data titled PS into the dependent list. I'm going to untick stem, tick the histogram, and tick normality plot with test, as I will use the statistical test in SPSS to work out for me whether the data are normally distributed or not. If I click on continue, then click in OK, SPSS generated a few tables, and if we look at the descriptive table, again this data shows that there is skewness in the data, 0.99, nearly 1, and the standard error is 0.2. And the software has used two tests, Kolmogorov-Sinrov and Shapiro-Willig test, to determine whether these data are normally distributed or not, and the test shows that they are not normal. Histogram again shows that these data are skewed to the right, so it's positively skewed. Now, how can I correct these data? So I'm going to use one of the options that is available to transform the data. There are three options, one of them to use the log 10, another one to use square root, and a third one is to use reciprocal. And to do reciprocal transformation, click on transform, compute variable, reset this, and I'm going to generate a column where the data on the PS column will be computed, and I'm going to call it inverse data. And the way to do inverse is to click on one, then divide this, make a division, and move the data into this. So we will going to inverse this data, and if we hit the button for OK, again data has been generated and all these cell content has been inversed. And to explore whether these data are normally distributed, click on Analyze, Descriptive, and then Explore. And I'm going to move inverse to the dependent list here, so to compare both. And I'm not going to do any changes. If you click the button for OK, so here SPSS had made a descriptive data for both. The positively skewed data, which has 0.99 value for skewness, when we inverse or did the reciprocal transformation on the data, the skewness has been reduced to 0.05, which means that these data are now normally distributed. Again, if we look at the test of normality, we can see that for the positively skewed, they are not normally distributed. Once we transformed these data using reciprocal or inverse, the data tend to become more normally distributed. If you look at the histogram, this is the data before transformation, reciprocal transformation, and this is the data after reciprocal transformation. So using reciprocal transformation in this situation has really converted the data from non-normal to normal distribution. And this will allow and permit using parametric test. So this is one of the options available to try to transform the data if it is not normally distributed or if it has an outliers